Okay, so let's go back here, because I did say add 1, and we had 3/2 up there. Did we make a mistake down here? Help me out here. I'm trying to race through this problem. Is there incorrect word here? If I'm here, I don't think we ever established it was at 3/2, did we, on here? Didn't have to, because we put f of 1/2 in, and we got that. So I think we're fine. Let's go back to this, though, because if I add 1, I should be up here. I'm going to establish a window, and I asked some of you to do that. I really don't need much on the negative input side, and I think I'll just take this up to 10 and scale by 1, and 1, and scale and go by 10 and scale by 1. Let's see how that looks. I'll change that just a little bit. Maybe make that a 5. Okay. So I've got this going here. I've got my point. I want what between them? A segment? Now I will warn you, what we need to do is actually put a line, because what I want to do next is not going to evaluate the segment the same way it does a line. So I'm going to go ahead, even though I realize it has to be a segment, I'm just going to put a line in there. Okay. Now, the reason that we need to be careful about what we're doing is I'm going to go to Menu, Actions, and I'm going to come down here to Coordinates and Equations. And if I point to the line, I can now check my work. If I just type that in, I may be missing those points just slightly, and I wouldn't know it. Now I see y equals 6x minus 1. Am I convinced that I've got the right analytical work? Yes. Okay, so that's the point I wanted to bring up. This whole idea of showing me your graphical work to go with your analytical work is that one step more of understanding. And we have to be able to do this. So please, for Thursday's quiz, you might want to go back to some of those problems and say, how would I show it or graphically? I can move all the stuff around the piece of paper, but so what? What do I understand about it? So be sure you can show me a graph. Yes? You don't have to. Well, can you draw a graph on your paper? Can you put 2 points down? Okay? And then you're just going to have to hope and pray you got the right line, because you can't check it then. But you got the technology. Yes?
How did you get it to do that? You went into Actions and then what?
Menu, Actions, Coordinates and Equations. Okay? Coordinates and Equations. Okay. So, I want you to have all the tools possible. I'm sorry, did I go by it too quickly, Kaylee?
Yeah, I just got confused because I didn't do that, but I had the same thing as you. So
Right. A lot of you, what I saw on your graphs, you actually typed in the new equation 6x minus 1. And again, it could be off just a little bit and you wouldn't know it. And so if you do it this way and you place that line through those 2 points, it will come up with the correct equation. Then you can check your work. Otherwise, you're just showing that you had an equation and you're hoping it goes through the same one. Okay? It's just one of those advantages of using the Inspire. Okay. So we did that. If I asked you for the others, do you think you could do that? And I think your answer would be yes. Now, we had the what if going on. What if we use delta x to be 1/2? What if we use delta x to be 1/10? On this graph, what is happening? What am I doing with this point if I use now a delta x to be 1/2 instead of 1? I'm moving the point to be what? Just Just got to verbalize. I pick up the point and do what? Move it closer to the original, right? Move it closer. As I move it closer, let's see if I'm just going to see if I can get it here to 1 or close to 1, because this would be indicative of a delta of, I had it almost, oh, close enough. It's indicative of a delta being 1/2, because now my first point's 1/2 and my second point is 1. What happens to my slope? Well, the slope is 4 at this point. Okay, so what if I move this point closer yet? So the second question of this was, and this is going now to what you did for the activities, as I move this point closer and closer to my 1/2, what happens to my slope? My slope becomes, as close as I can imagine, it becomes the slope of what? The tangent. So if I ask you to show me graphically the slope of the tangent, you're going to have 2 points, right, to determine a line. That comes from your geometry. I don't have 2 points if I have a tangent. I have 1 point. Menu, let's see. Menu, there we go. Under points and lines, you can actually have a tangent. So if I take the tangent at 1/2, and let's see if I can get the other point to move out of there now. Oops, the other point to move out of there now. There we go. So there's that secant. This is the tangent. How do I determine the slope? Because actually, how do I determine the equation of that tangent line? Menu, actions, same thing, right? Same thing. There's the slope of that tangent line. So as I move this point closer and closer to my original point, the slope of the secant should become closer and closer. The slope of the secant becomes almost how much? 2.77. Okay. Do you see a limit in this? We've been talking about limits. I say this section belongs in the limit chapter. Do you see? Could you write a limit statement, a limit problem for this? Let's try it and see. What's changing in the slope formula as I move this point? Well, everything is. Okay, let's get a little more let's get specific here. What did I change over here? Delta x, right? In the slope function or slope equation, I'm changing the denominator. As I move this point closer and closer, what is delta x becoming? Delta x. Delta x is not becoming the slope. Delta x is what now? What's our difference? What difference in the inputs? Delta x is becoming 0. 0. 0. Okay? So as delta x gets closer and closer to what? As 0. As delta x gets closer and closer to 0, what's happening to the slope of the secant line? It's becoming what? As I move this point closer and closer, as delta x gets closer and closer to 0, the slope of the secant becomes the slope of the tangent. Is that a limit statement? Is that a limit problem to work on? Could we write that as a limit? What we are going to be doing is just that. We're going to be asking, as as delta x approaches 0, the slope of the secant approaches that's a limit statement. Okay. How do we write that? The limit as delta x approaches 0. And how do we determine the slope of the secant? Difference of the outputs? How do you write that? Divided by delta x? Because I don't know how to over. Okay, yeah, but this is it. This is our limit statement. And this is going to give us, so this is the slope of our secant. This is the slope of the secant. And it's going to be approaching what? Slope of the tangent. That's what we're about. That's what this whole course is about. That's it. You know it all. You might as well go home now. Okay? But seriously, that's all we're about. Now, what name do we give the slope of the secant? Or excuse me, the slope of the tangent? The derivative. Yes. That term, derivative, means nothing else than the slope of a line that's tangent to a curve at a point. That's it. That's it. That's all. Can you find the slope of a line? Sure you can. All you need are 2 points. But the problem with ours is we're doing it at a tangent. And how many points on the curve do we have if we do a tangent? 1. So how do we get around that? We just bring that little secant to be closer and closer to be in the tangent. And voila. One of my French words. There it is. Okay? There it is. We use our limit. This is why this section really belongs, in my opinion, belongs in Chapter 2. Because it's all based in limits. Now, I'll give you a hint that after we get through with Section 3.1, we don't have time to go back and always do a limit problem. So we have a few shortcuts we take. The shortcuts are things that for thousands and thousands of years, mathematicians have been working these out, and they go, you know what? We're working too hard. Did you ever notice that if we did this, this, and this, we get the same answer? I'm going to take the shortcut. And so they take shortcuts, okay? But it's all based in this. This is what a derivative, this is why I wanted to be here with you guys, okay? I didn't want to put it on a video and just have, and go through it. Because this is so important. This is the whole idea. Now, we've got about 7 minutes here. Oh, well. I messed it up. I guess I'll mess it up again here. Okay. Definition of a tangent line with slope m. There it is. The limit as delta x approaches 0 is delta y divided by delta x. How do we determine delta y? F of c plus delta x minus f of c. We actually are going to put x's in there. So we'll have f of x plus delta x minus f of x. And it's the slope of the tangent. That's what we're coming up on. Okay. Again, I hope those activities have helped you through this, to give you some other thought before we got here today. Because if it did, you're much farther ahead than other semesters. Okay.